You know when you wake up in the mornings and you feel like you have like a layer of something around your teeth? The same forms around your ligaments and your nerves and so forth. And when you do that, you clean it, basically.
Can you use like a brush?
Okay, right. So now we're going to look at calculations when we have a position time graph. Now we just said that the velocity is determined by the gradient. The velocity is determined by the gradient. If the velocity is constant, then it will form a straight line. Now a straight line does not mean horizontal like that. Okay? Straight line I mean like that, or like that, or like this. Okay? So just a solid straight line. When there is acceleration, meaning it goes faster, 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 then your graph will be curved like that. Okay, or it will be like that. Depends what type of acceleration it is. Okay. So it says here, calculate the velocity of the object using the following graph. Okay, now you should know, okay, if they ask the velocity, they're basically asking I must calculate the gradient. Okay, so you're going to say velocity is equal to the gradient, which is the change in y over the change in x. And for this graph specifically, the y-axis is x and the x-axis is t. Okay, make sure you don't just copy, but you actually understand what you are copying. Okay, so we need the change in x, the change in time. We need 2 points on this graph. Okay, now I actually need to find that. Okay, this is obviously my skill on the computer. Okay, so my aim was that at 60, it is directly over 400. Okay, so that's 1 point that we can use, 460. Did you take out your ruler? Did you make dotted lines? Okay, another point that we can use there is the origin, the starting point there at 0, 0. That's an easy one. Okay, so this is our initial point, this is our final point. Okay, so we have there, the change in x, so we're going to say 400 minus 0 over the change in y, 60 minus 0. Because it's final minus initial. So the change in x, you're going to say that's 400 minus 0. You must fill in the 0. And the x-axis, we have 60 minus 0. And then I want you to quickly calculate that, please. Right, where are we with our questions? Kutlano, what did you get? So that's what, 6.67, 2 decimals. 6.67, and what's the unit, Kutlano? Meters per second, because we have meters divided by seconds. Okay. Right. Now it says here, calculate the instantaneous velocity. Tsepo, what is instantaneous again? Say again? No? It can be constant. It don't have to be. Instantaneous. Huh? Yes, Sipo. Immediate. So we want it immediately or for a short, a short time frame. Okay. Now, because this one is curved like that, okay, because it goes for a curve, we can't have a constant velocity. Here it's going slow, here it's going fast, like you did with acceleration in the practical. Okay, so we can't say, oh, I'm going to take this point and get the velocity because it's for too long. It changes too much. So if it is curved like this, we use instantaneous velocity and we're going to get it for a very short time frame. Okay, for 1 split second, almost. Okay, so if they ask you calculate the instantaneous velocity at 4.5 seconds, then you're going to look at from 4 to 5 seconds. Okay, so you're going to take it for 1 second, one time frame period. Okay, so we're going to take it from 4 to 5 seconds. Okay, so from 80, now that's a bit skew, but to 100. I did 100. So then 4.5 seconds is somewhere in the middle. Then we'll get the average there, somewhere in the middle. Okay, so instantaneous velocity, you're going to look at a small time frame, but your calculation will look the same. Sorry, velocity, you'll get from the gradient, which is the change in y over the change in x. For this one specifically, it is the change in displacement over the change in time. Okay, so Sipa Batso, what are you going to fill in there? What minus what?
No, aren't you going to say 100 minus 80?
Yes.
Then 5 minus 20.
Mooi. Lesedi, are you on it? What do you get? In your head. Yes? 20 what? Dankie. 20 meters per second. Alright. So grade, what are you? Dankie. Grade 10s. Your homework is the following. On page 20. And I see you tomorrow, first period, so don't leave it for break. On page 20, you have to do question 1. It's a multiple choice question. Question 2. Just wait. 2. Question 3A and B, not C. Question 3A and B. Question 7. Okay, only that.